Hola. Buenas noches, buenas tardes, donde sea que estén. Muchas gracias por sumarse a esta pequeña charla que nos va a dar Vinicius. Muchas gracias por sumarse a esta pequeña charla que nos va a dar Vinicius en unos minutos nada más. Primero, agradecer a todas las personas que hicieron esto posible, a la gente de Nogma, a la Escuela de Creativos Nogma, a Copublicitarias, a Lowe Delta en Ecuador, a Genosha, a Rack y sobre todo a Vinicius y a todos ustedes por estar del otro lado de la pantalla. Ahora vamos a comenzar con la charla que, como habíamos dicho en su primer momento, va a ser completamente en inglés. Así que, Vinicius, te dejamos ahora todo hacia ti. Estás. Perdão. Você pode ficar falando já agora. Já está sendo apresentado na tela, em primeiro plano. Está aí, está
Buenas
lá.
noches. ¿Me
Então,
escuchas?
todo perfeito. Então, valeu e deixamos. Perdão. Los dejamos con esta pequeña charla y después estamos abiertos a todas las preguntas que requieran de Vinicius. Entonces, todo seu, meu bem.
Let's go. So, good evening. Perdón por hablar inglés, pero mi vocabulario en español no es tan bueno. Entonces, vamos en frente. We're going to talk today about artificial intelligence, and I have decided to organize the content in 3 times. The first time is what's going on right now, what is happening all around the world using artificial intelligence. And the second part is what is going to happen next. How will AI evolve, and what can we expect from it? And the third part is about where are we going to, what AI can do for us as human beings, as a society, and where will it drive us to. I always like to start talking about artificial intelligence and discussing about what is intelligence, because we have a lot of questions when we say applications. Some people say, oh, but this is not AI. Oh, this is AI. And we are, sometimes we lose in order to not use my own word in a so complex issue, I use P1 words and as the capability of a system to adapt to its environment and to work with insufficient knowledge and resources. So we're talking about systems that do not have all the software, all the information, all the data, all the logic, whatever. He is not able to attain a perfect answer. So an intelligent system deals with scenarios, and it understands what 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 option has the greater probability to be right. And so when we talk about intelligence, we are also talking about probability. We are also talking about the statistics, although sometimes we do not think that we as human use probability and the statistics to reason. But in fact, what we are doing all the time is looking for the solution that has the greater chance to work. So we are talking about probability. And this is how I used to define a system as intelligent. It's a system that is not able to have the exact answer, but to deal with probabilities and find what is the most probable right answer. Beside this, an intelligent system is also able to learn. An intelligent system may give you an answer right now and this year, and if you make the same question next year, next month, or maybe tomorrow, maybe he will give you a different answer because he learned different, not new concepts. So this is what we define as intelligence, and this is what we use for defining artificial intelligence. So artificial intelligence is a system, an artificial system that uses intelligence as we defined. And how is this all being used today? What is going on now? We have a lot of solutions nowadays using narrow AI. It's the first concept I would like to share with you. Um, when we talk about intelligence, we have basically two kinds of intelligence: narrow AI that we are going to talk right now, and artificial general intelligence that we are going to talk a little bit ahead. Uh, Narrow AI are specialized systems that are able to solve specific problems. So we have an intelligent system to drive cars, and so we call them autonomous cars. We have intelligent systems for cancer diagnostics. We have intelligent systems for customer care, healthcare, and we have a lot of specific systems with specific intelligence able to solve a specific problem. This is narrow AI, an intelligence made, trained, an intelligence that has learned to solve a specific problem. We do not have right now an intelligence as the movies, as science fiction movies, as the Terminator or something like that. But we do have many intelligent systems that are able to do specific tasks. Um, and also, when we talk about artificial intelligence, it's important to know that we are not talking about a brand new issue. In fact, um, artificial intelligence, the term was born in 1955. It was when John McCarthy has used it for the first time, this expression to define the science and the engineering of making intelligence machines. So it was the first time. And even chatbots that maybe sometimes we used to refer as brand new technology. The first chatbot called Elisa was made in 1964. So chatbots are also are neither a brand new solution. And what happened after that is that between the 60s and the 90s, we had the first AI winter, when many false starts, many products went wrong, and people stopped. Many people stopped to talk about, to research about, and just just a few researchers um, continued to work on it, and maybe not making any noise, just working in the background. So in the end of the 90s, when Deep Blue in 1997 has won Kasparov in a chess battle, we came back with the the discussions about artificial intelligence, and IBM was was responsible for that moment. And since then, we we are hearing about artificial intelligence, and we have again a gap between 2002 and 2011. Uh, where again artificial intelligence was not the focus of the media, of the development, of the research. But um, recently, after 2011, uh, the new techniques for deep learning have bring back artificial intelligence in a very popular way, and we must see here IBM Watson and many other platforms delivering artificial intelligence as services, as cognitive services, and so it has it became much easier to develop a system with artificial intelligence thanks to these APIs, these platforms that we'll talk a bit more ahead. So what we have right now is a set of tools, maybe for cognitive services, as I told here, or maybe using other techniques as we are going to talk right now. So if we want to develop a system using artificial intelligence, we can use, for example, cognitive services from IBM, from Microsoft, from Amazon, from Google, and so on. So what do we win when we use cognitive services? We win a lot of time. We gain time. It's much easier, much faster to develop a system, an intelligent system, using something that is ready from IBM or from Microsoft, for example. But sometimes these APIs, these services, are not enough. Maybe because they do not have the feature we want, or maybe because they just don't provide the results as we would expect. So when cognitive services are not the perfect solution, and it may also be concerning costs, uh, it may not be affordable, and so when cognitive services are not enough, we have other ways to develop, for example, using open source tools. For example, OpenCog, that is the platform developed by the engineer, Bangerzo, who is the engineer behind Sophia, the robot from Hanson Robotics that made a lot of buzz in the media, has won the citizenship from Arabia. So Ben Goertzel is the engineer behind OpenCog, a platform where you can develop an entire ecosystem for cognitive services open source. We have also OpenAI. I have chosen 3 examples of open source tools, but we have a lot of them. For example, for Python, we have a lot of libraries, open source libraries. I have chosen 3 here. OpenAI is a philanthropic project that does research and also development. So if you go to the OpenAI website, if you go to the OpenAI website, you can find some results, you can find some systems for downloads, and so you have very rich features there, very rich platform for you to use. It's if you are wondering about using open source platforms or wondering about studying artificial intelligence open source tools, you may take a look at OpenAI. And OpenCV is an open source library for computer vision, where you can give your system the ability to understand images, still images or videos. So your system may recognize what is going on around him. It's a complete open source library, mostly used with Python programming language. I am giving some technical information here, but I swear we will not long much. We will soon go to business questions, uh, and so it will be more palatable for everyone. Um, and maybe we have some situations that open source tools are not enough also, uh, maybe for not having the the features we want, or maybe because they are too complex for the situation we want. And so we can also talk about developing our own algorithms. We have basically three kind of algorithms. Here it's not the case to specify each one, because the talk would become really hard. And so I would like to tell you just that we have three kind of algorithms when we decide to code our own artificial intelligence. And the first one is regression. When we use to make value prediction, we want to estimate something that it's numerical. We have classification algorithms that we use for categorization, for example, to decide if the animal that is coming in the video is a tiger or a dog, uh, to decide if what is moving in front of me is a person or is a bike, for example. This is These are some examples of classification. And clustering is the last kind of algorithm that we use when we do not know how we want to group. For example, we use clustering algorithms for customer segmentation. We have a lot of customers, we do not know how to split them into subgroups, so we use clustering. And so the algorithm will itself find the correlations and how what is the best way to divide this group. So that's what I would like to talk in a more technical way, just for having a panorama. And let's talk about what people are doing right now with these techniques that we talked here. Um, for example, in healthcare, we have here in Brazil a company called Laura Networks. In Portuguese, we say Laura, and it runs at many hospitals in Brazil, and it has already analyzed data from 1.2 million patients, and the numbers show that the mortality from sepsis, a general infection, uh, has dropped from 30% to 22%. And with the system, they also reached a reduction in the length of the hospital stay. It's a Brazilian solution. It's a very beautiful but sad history of the entrepreneur. He had a daughter. He lost his daughter named Laura, and so his mission is to save lives using Laura. It works on hospitals, and the mission of the system is to tell the doctors who is the patient with the worst condition at this right time. And at this panel, you can see in the in the TV in the wall, it becomes every time showing where should the doctors pay attention and go right now. Another good example regarding healthcare is about cancer diagnosis using Watson for Oncology. It's by IBM. And although many people criticize Watson for Oncology, saying that IBM uses a lot of market about it, I prefer to rely on scientific studies. And so this study right here that I'm showing you, you can Google for it at Google Scholar. You have the reference right down the screen. Um, and they have driven a study, a 1 year long study at India, and they submitted 1,000 exams for Watson and for a group of doctors, 12 to 14 doctors uh, was the quantity of doctors analyzing the same information. So if we consider that the doctors were right, uh, Watson was also right 90% of the times. So if we are talking about 1,000 patients, Watson was right for 900 patients. What we see here is a discussion about, oh my, we're talking, you're saying that he was wrong for 100 people and this could cause them to die. Yes, sorry. But what we also say here is that the system was right 90% of the time compared to the best doctors in India. So if we compare the system with a regular doctor around the country, uh, I think that it will be right more times than the regular doctor, and not oncologist doctor would be right. So what we have here is a great augmentation solution that may help the doctor that is not able to have a diagnosis by himself. He may use Watson as an assistant to have a better diagnostic and prognostic. So I think we are moving very well in cancer diagnostics with this kind of solution. About security, we will talk about a lot about what AI may be dangerous, how AI may be dangerous, and how can it hurt us. And we will talk about risks uh, ahead. But I would also like to tell you that artificial intelligence is also used to provide security. For example, the system from Hitachi, he used information from security cameras, from microphones, from social media, from calls to 911, and he uses all of this information to plot a heat map of the regions of the city that have that have more probability to have violent incidents, and so they can send the the policial force for this region, preventing the incident to happen. We are not talking about that old movie Minority Report by Tom Cruise, uh, where the the those people could predict that you would murder someone and you would be arrested before the murder. No, we're not talking about that yet, but we are talking that we can uh, predict where we have more risks and send the policeman there. It's a good measure for enhancing security in the cities. Education is also, so we're talking about healthcare, security, education. These are all basic questions uh, for human life. So we are really talking about important solutions. And when we talk about education, I like a lot of the example from Duolingo. I'm also a teacher, and as a teacher, I know how difficult it is inside the classroom to deal with different paces, to deal with different needs from different students. So what Duolingo does is Duolingo has a chatbot that talks independently independently to each student. So it's like it's somehow we had a a dedicated professor for each student. And when the student talks to the chatbot, writes, the chatbot is a written chatbot. When the student talks to the chatbot, he receives feedbacks on what he does have to study a bit more. So he has uh, um, somebody that is looking for his own necessities, his own difficulties, and this is a great way to make a personalized education with automation by artificial intelligence. When we talk about law, I we are we hear a lot of discussion about the new role of the lawyers. Um, and really we can use artificial intelligence to make basic primary, not basic, we can use artificial intelligence to make the primary analysis and to study the jurisprudence, for example, that will be used in this case from JP Morgan, an artificial intelligence system called coin does in few seconds what the lawyers use it to spend 360,000 hours to do. So we are really talking about a great potential for automation, uh, even in law. And talking about e-commerce and digital marketing, it's uh, uh, a kind of segment that we have a lot of investment also. For example, from Alibaba, they have an intelligence system called Luban. And what Luban does is to make in real time uh, personalized banners for the visitor accessing the website at that moment. So, for example, in China, they have the Singles Day. It's a day when they are used to shop a lot. And in 2 years ago, the system Luban have made in a single day 400 million banners, personalized banners, using the information about the customer, about the visitor, his preferences, his information to provide in real time a banner with the product and the information the e-commerce wanted to show to that individual customer. So it's fantastic. It's a high level of automation. Also about digital marketing, we have a lot of artificial intelligence systems for brand monitoring. What you see here on the screen is a prototype that we have made here in Brazil for analyzing the results of a Facebook fan page. So with these systems, we could analyze the engagement from the customers and analyze how the customers reacted to each kind of post. So and also monitoring the incidence of the name of the brand in the internet, in social networks. Uh, and this is used both for making better market decisions and for providing um, risk management decisions, because this way they were uh, um, the managers had the information about crisis in first time very quickly and could contact it directly with the one that has just posted. If we are talking about an influencer that has made a bad post about my brand, I want to talk to him very quickly in order to solve this issue the faster as possible for uh, for it not going viral. And still talking about commerce, the chatbots are an issue. It's very difficult to talk about commerce and artificial intelligence and not talk about chatbots. Chatbots are not synonymous for artificial intelligence, as um, sometimes people think. We even have chatbots that are not intelligent. We have chatbots that are simple decision trees, but we have chatbots that are intelligent, and chatbots with intelligence are chatbots that are able to understand what is the intention of the user. So when the user enters the chatbot and types something, the intelligence behind the chatbot is to answer the question, what does this user intend to? And so the intelligence of the chatbots is simply to understand what is the intention of the user and, of course, solving this intention, giving him the information or the action he expects to. And the last issue, the last topic, talking about application, is about environment. Um, I work with design, with human-centered design for a long time, and I am very worried about how can we use technology to have environmental responsible solutions. I have here two examples. The first one is from Shanghai. And what we see here is the Pudong channel. And the Pudong channel that you see here is is a channel that crosses Shanghai, and it it's reaches the sea. And Shanghai used this channel to pick its water, and they use artificial intelligence to control the gates. And using this system, this intelligence system to control the gates, they prevent flood. They they are able to uh, pick the water where it has less salt for at that time, and even deal with pollution, picking water where it has less pollution at that time. So a great application. Here in Brazil, we have a prototype for aquatic fauna monitoring. And what you see here is a computer vision system using OpenCV that I told you some minutes ago. We used here OpenCV to understand in a video if what we had there were fishes or not. This is used to understand if in a place where you did not expect to have fishes, they are there, or in the other hand, if if you want to have fish in some place, use this kind of system to count how many fishes you have at that place. I cannot say a lot about the whole application because of confidential terms, but I can show you here that we have technology for using for understanding what is going on even underwater. So with all of these technologies, where are we going to? Kevin Kelly, the former editor of Wired, says that everything that is connected to electrical power will be cognified. What does he mean with cognified? Um, he's saying that objects devices will be more intelligent. They will be able to understand the context where they are. They will be able to interact with the environment where they are inserted. Um, so the same way that in the past we had a lot of mechanical devices, and these mechanical devices became electrical devices. Kevin Kelly says that now that they are electrical, they will become cognified, they will become intelligent, and they will be able to deal with the environment. And this speech from Kevin Kelly connects with another issue, that is the interface revolution. Uh, Today, we have basically two main kinds of interface. The first one, the screens, the screen of my notebook, and the screens of my mobile phone, and I use to type using keyboard, mouse, or if I in mobile, the other interface is the touch interface. So we use typing interface and we use touch interface uh, mainly, and we are moving to a world that will not be mobile first anymore. The world will be AI first, because as Kevin Kelly said, uh, the devices, the objects will be intelligent. And as Sundar, the CEO of Google, says, uh, in the next 10 years, we will have computing universally available, home, at work, in the car, on the go, uh, and we may interact with the systems in a much more intelligent, in a much more narrow, intuitive way. Um, so uh, it does not make sense when I want something, I get into a website and have to scroll and have to exit the pop-ups and have to accept the cookie and have to make my login, and have to inform my email. I have to do a lot of things until I can reach the information I want. It does not make any sense. So with the concept of the interface revolution, we are saying that we are going to access the systems and reach what we want in a much more natural way. And what Gartner says for 2020 is that voice will be the main interface, at least not main, but 30% by 2020. 30% of web browsing will be already done without any screen. So we are we we are saying that I will provide a voice command, and I will hear a voice feedback. Um, and it makes a lot of sense, because we can see Google Home, we can see Alexa, we can see the assistants in our smartphones. We can see all of these things happening, so it makes a lot of sense. um, and things are changing really fast. What we see here is a study by Ray Kurzweil, is the accelerated returns law by Ray Kurzweil. Uh, what we see between 1960 and nowadays is the Moore's law, and what we had before were vacuum tubes, were electromechanical computers. But since electromechanical, what we see here is that the technology uh, evolves very quickly in an exponential way. So uh, in 2015, we have already reached the brain power of a mouse with a 1000 computer. By 2023, we expect to surpass the brain power of a human with $1,000, and by 2045 we expect to surpass the all the human brains capacity with $1,000. So uh, uh, things are changing really quick. Uh, the gray part of this graphic um, is still incognite, is still unknown, because we do not know what will be the next generation of computers. We see here that we have evolved from electromechanical for transistors, for integrated circuits. So what is coming next? Well, we have two candidates for what is going next. Maybe we will choose one of them or both. I don't know really. The first candidate for uh, substituting the integrated circuits is the quantum computing. And what we see here is a brief explanation what changed from actual our current computing systems is that we have one or zero, we have bits, we have yes or no. It's what we call today of digital electronics, digital computers. It's a digital system, o or one, zero or one. And when we talk about quantum computing, we do not have just two states. We have a lot of states that corresponds to the quantity of qubits on on the system. Uh, so the, the computing power using quantum systems is totally different. For example, all of our crypto crypto that we use to secure, for example, our passwords today would be easily broken with computing systems. So it's an issue that we have to think about. And we are in the edge of uh, of an evolution, um, of a jump in the evolution when we change from transistors, integrated circuits for quantum computing or for neuromorphic computing. It's not so famous as his brother quantum computing. Neuromorphic computing is an alternative. I don't know which one will be choose. But neuromorphic computing is not like neural networks, because neural networks are about software and neuromorphic computing are about hardware. Basically, what a neuromorphic computer system does is to use both analog and digital signals. It emulates the human brain, the neurons, and so it it's much more efficient in terms of energy. So we have much more computing power with much less energy, um, and it also, as it has analog components. It's not limited to O or 1 to 0 or 1. It has a lot of different amplitudes typical from analog signals. So uh, even computer systems are looking for the diversity. We even computer systems will not be yes or no. If we're talking about quantum computing or neuromorphic computing, we have a lot of information between O and 1, between yes and no, as the life is. So I am very happy that our electronics are evolving as we as humans also do. Um, just to to have a proof that we are moving ahead in the direction of having the capacity of the human brain. This is Summit. This is the faster supercomputer in the world, and he's able to deal with 10 to 17 uh, floating point operations per second. Nick Bostrom, by 1998, said that the human brain is able to make 10 to 11, 10 to 17 operations per second. And Kurzweil, by 2005, said that the human brain is able to do 10 to 14 up to 10 to 16 calculates per second. So we are not talking about um, the same thing. We have in one hand floating point operations, we have in the other hand operations per second, and we are not talking about exactly the same thing, but we have here an idea that the the proportion are similar, and we are next to the human brain computing power using supercomputers. In the future, maybe it will be in our hands, as the supercomputers of the past are already in our pocket with the smartphones. Um, with all of this, uh, maybe we will reach an artificial general intelligence. And as Bangorto defines, an artificial general intelligence is a system that is able to deal with different and complex scenarios, and is able to solve problems that he was never teached to. And so it's an intelligence that combines many kinds of knowledge, many capabilities, many skills. And Ray Kurzweil, for example, says that we will have AGI by the next decade. Um, what I have to tell you is that I believe that we will have computing power for that, and we have a lot of research, for example, by Bangerto, uh, intending to reach AGI. I'm not sure that it will happen the next decade, but who am I to say it? Ray Kurzweil thinks so. I cannot tell Kurzweil, oh, you're wrong, man, because he studies much more than me. But I'm still static about this. And I know it's possible, but I don't know if it will really happen. So we will have to live to see. Um, and so if it really happens, if we have this scenario of artificial intelligence evolving so quickly, so fastly, if we reach AGI, where are we going to? We have maybe, if we look in an optimistic way, we may think about utopic scenarios, and oh, we are going to solve all the humanity problems, we will live happy forever, as Walt Disney movies. And some people say, no, 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 no. We are reaching the doomsday. The machines will understand that the human being is not good for the environment, is not good for Earth, and let's eliminate the human being, and we will have a machine revolution, and everything is going wrong. Um, so the Future of Life Institute, for example, is an institute that studies this kind of scenario all the time. And when we say about dystopic scenarios, um, we have the first worry is about social inequality. So if we think about the Limitless movie, we see that the resources, the technology, the long life costs a lot. So not everybody will be able to will afford these new resources. Talking about Elon Musk, for example, and the SpaceX, he's going to take people to Mars, but who will be able to pay for it? We, I don't know. The millionaires, maybe, um, maybe we will have to be here on Earth, on a devastated Earth, and the ones that have a lot of money goes to Mars. I don't know. We have to think about it. How can we provide the people that do not have enough money, uh, at least the basic, at least what they need to live with dignity and to be happy, because the the risks for social inequality are real. Another risk for talking about this topic scenario is about bias. Uh, if we teach machines, if machine learns with us, if machine learns with what we have done, so maybe we can automate, we can make the machines to repeat the things we already do wrong. And we have a lot of examples of machine repeating human behavior in not as expected way. We have example in the US, the compass system that is racist and is and used to to think that black people are then more dangerous than white people. I can send you if you want the link for this study. We have the bot Tai from Microsoft, and 3 4 years ago, that learned at Twitter to act as a nazist, as a racist. And so the risk of teaching machines to act like humans may teach them to have the same bias that we have, or maybe even if it's not intentional, maybe the machines may learn the bias that is incrusted in the data. So we have to pay attention for it. And at least at last, the risk of autonomous weapons. We have on the right, on the left, the Fedor. It's a Russian robot that is able to shot Glock with two hands, uh, with high accuracy. It's a real project. It does exist. And in the right, you see a video that was. So these are still images took from a video that the Institute for Life has deployed uh, last year, showing that with a simple drone that can be in our hands, it using computer vision, it could search, uh, identify targets, and blow an explosive in the head and kill it instantaneously. um, a sort of intelligent weapon. So this video was intended to generate awareness that autonomous weapons are dangerous. And it should be prohibited, should be regulated. We should not develop autonomous weapons as a society, as humanity. So it's really an issue. Well, that was all bad news. So let's talk about good news. When talking about utopic scenarios, we see, for example, the initiative from Elon Musk with Neuralink. It's a neural implant inside the brain that will provide us with the ability to interact with computers, with digital systems, without having to say anything, without having to type anything, without having to touch or click anything. We just think, and what we think goes to the computer as a command. So in technical vocabulary, we call it a brain computer interface, BCI. And when we mix it with um, trends like quantify itself, for example, uh, we are in control. We have our body under control, and we are able to monitor and interact with our body. And we follow this development with prostheses, ortheses, exoskeletons. Maybe one day, with all of this technology inside or outside the body, we may think about devices that are so common, so natural as glasses, and so a wheelchair becomes museum equipment. So, because if you see these pictures, when we look at a human in a wheelchair, uh, we know it's difficult for him to to move around, to do the things he have to do. But when we look at the right, the woman with the glasses, it's a technology that is absolutely natural, common, and she can do anything she wants. And what I hope is that in the future we have so much control of our body that we will have technology, for example, for this solution, for this scenario of the wheelchair will not exist anymore. It's what I hope and what we are really moving forward. You can Google, for example, for Hug Hair, the director of biomechatronics at Massachusetts Institute of Technology, and you will see what he's already doing with prostheses, fantastic prostheses. It's really marvelous to see it. Uh, Also, yet talking about utopic scenarios, um, we hear Domenico De Masi talk saying that with so much automation, maybe we as humans, we will not have so much work anymore. So the work needed to to live on earth, maybe if we share it in a new way, for example, if each of us work 3 hours a day, we can deal with everything we need, and we can use the extra hours to art, to playing the guitar, to the theater, for playing some sports. And so maybe we are going to live the new renaissance, but now not a renaissance based on uh, slavery or exploration of overseas. We are talking about the new renaissance, based on technology, based on the work of the machines, not the work of the slaves. It's a good way it's a good point of view. Well, we have utopic scenarios, we have dystopic scenarios, and the last good news is that at Stanford, the University of Stanford in the United States, we have a project called AI 100, and what they do there is 100 years study on artificial intelligence. For example, in 2017, they made a conference and they have get together the best researchers uh, on artificial intelligence and multidisciplinary teams, and they divided themselves into two subgroups. The red team was responsible for wondering what could go wrong. to wonder what would be the scenarios, what would be the trajectories, how could artificial intelligence go wrong. And the blue team was responsible for defining countermeasures. So it's kind of good news to know that uh, we know that there are risks, but we know that there are intelligent people uh, working on that, working to mitigate the risks. So I think it's really good news for us. Well, I have said a lot. I am at the end of my presentation. I would like to just give you the last information. I work with workshops, lectures. I am also an entrepreneur on development, system development. But much love, what I love more, is to make workshops and lectures. So feel free to call me. I have workshops, hands-on workshops, building autonomous vehicles. Here you have the one in the picture there. It's electrical car with a Raspberry Pi. It runs OpenCV here inside, um, and we can teach this guy to drive autonomously. And the other picture in the right is the prototype of a robot I am making right now in a workshop for building a virtual assistant. So we can do it in real time if you want. Here are my contact info. I feel that I have said a lot. I am a long time here speaking, and now I would like to hear a bit from you. Thank you for the patience.
Valeu, meu grande. Muchas gracias a todas las personas que nos están escuchando. Ahí están reunidos también en Ecuador. Un saludo a la gente de Ecuador y de donde nos estén viendo todos. Y ahora me van a mandar un par de preguntas para que. Now I mixed up in what language to speak. They will be sending me questions shortly, Vini. Si tienen más preguntas, por favor, dispárenlas. Muchísimas gracias de vuelta, Vini, por el tiempo. Ahí tienen los contactos para que se puedan hablar con Vini y nada, charlas, hace workshops, hace robotcitos copados también. Entonces, sin más, ahí ven las preguntas. Y un ratito te dejamos ahí con tus contactos. ¿Alguna pregunta que tengan acerca de lo que vieron, no vieron? Lindas referencias para mandar. No, I really enjoy your references, by the way, Vinny. Most of them I really didn't know. So, okay. So here's the first question. How do you think the future is going to unfold? Is going to become utopic or dystopic, in your perspective?
Okay, good question. Every time we face a disruptive technology, we think about what can go wrong, and when we think a lot of what can go wrong, we see a dystopic scenario, or we start to wonder and dream about how life could be better, and this way we reach a utopic scenario. But what uh, historically happens is neither an utopic or a dystopic scenario. What historically we have when we face a revolution, we face a new technology or a new social movement, we have some good things happening and we have some bad things happening. Um, I believe we are going to face a lot of things going wrong uh, because artificial intelligence and machine learning are becoming very popular, and so many companies and people are going to try it, and a lot of things are going to go wrong. We have examples of things that went wrong. For example, the autonomous Uber that has killed a woman. We have the Microsoft bot Thai that became racist, and so on. We have a lot of examples of things that went wrong. But we also have a lot of examples of things that went very well, very right. So I do not think we will have a Mad Max scenario, a complete war, utopic, dystopic scenario, and I don't believe also that everything is going to be fine. Every little problem will be solved. I believe in a midway, some a bit of good things, a bit of bad things.
Awesome. Now I have a question from Argentina, and the question is, how do you see artificial intelligence apply to content creation?
Good, good. Um, it's a common question to ask about the relationship between artificial intelligence and creativity. And content creation is sort of creative uh, task. Um, Artificial intelligence is able to automate tasks in a very intense way. And when we talk about creativity, many of the part of the creative process may be mapped and repeated. And we have already examples in this way. For, we have the Flow Machines project by Sony, where an artificial intelligence is able to compose musics. You can search at Spotify, for example, SKY GGEs, if I am right. You will find a complete album composed by artificial intelligence. If you look for the paintings, okay, the paintings, not really paintings, from Google DeepMind, you will find some kinds that it looks like a creation. Um, and we have tools for natural language generation. Uh, it's the technique that we say for generating texts for based on the information that the system uh, has found. So for content creation, if we look at the banners by Alibaba, Luban, that they were already able to deal with the graphic elements of the banner. And if we combine it with natural language generation techniques, uh, we can see in a near future the automation of content creation. And there are companies that are researching on that. Did I answer? Is that okay?
Let me see. I think so. But in the meantime, we have another question. Do
Good.
you, from again Ecuador,
Hola.
going just see. Do you think the AI is going to create a new gap between people that are trained to use them or generated and those who are not?
Wow. Good question. We will have gaps in many points of view. For example, the first gap is between who can afford to have uh, an intelligent virtual assistant and the ones that who cannot, for example. We have the gaps between the countries that may invest in artificial intelligence development, and the countries that cannot. And as the technology evolves much fast, um, the more you invest, the more you make this gap uh, larger. But when talking about the gap of the ones who know how to use the technology and the ones that do not know how to use the technology, what we do expect when we talk about interface revolution is that the technology becomes transparent. So today it's difficult to use the computer. For us, maybe not, but for my grandmother, uh, it's difficult because you have to set up a different mindset to operate a computer. You have to set up a different mindset to operate a smartphone. And with the interface revolution, what we do expect is that we will not have to set up a different mindset to interact with any device. We will just interact with the device as we would interact with another person. So this kind of gap I don't see, but we will have a lot of gaps. And but if you a guy or a company that deals with technology, that develops products and services, and you as a professional, as a business, do not understand the new way of developing, uh, the new way of delivering goods, delivering services. If you as a professional or as a company don't understand this new way of doing business, you will be in the lower place of this gap, and it will not be good.
Awesome. Are there any more questions? Perdón. ¿Hay más preguntas? ¿Alguien con más preguntas? Si no lo dejamos ir, les agradecemos a Tuti la buena onda. Bueno, I do have a question, maybe to wrap
Go
it
ahead.
up. You said that there might be some gaps between countries and probably learning how to. Do you think it is necessary for people to understand or grasp at least the main concept of AI in early ages? Let's say pre-teens and teens. Do you think do we need? And if so, how can we implement those type of knowledge in that demographic?
Good, good. Oh, it's a great challenge. I do not have an answer. I have some thoughts. Um, and the first thing is that we must proceed with a technological education. I'll be clear. My son, for example, is 14, and he told me he's going to be a doctor for animals. I don't know the exact word, veterinário, doctor for animals. And we were talking about the necessity of him to study electronics. He did not intend to study electronics in the beginning, and so I told him, "Hey, man, uh, every and each profession in the world will be changed by technology. If you want to be a good doctor, you will have to know how the equipments work. You will have to understand how to choose the better equipment for your activity." And so the first step is to work on a technological education uh, in a way that every person understands how a software works, how the technology works, and so on. And when we talk about these basics of technology, we we must talk about artificial intelligence. So also, it it's kind of a basic education. Sorry if I do not have a straight answer, because it's really a challenge for everybody, and it's a $1 million question. I am working a long time searching for the answer for this question.
Oh, thank you very much for that, Vinicius. Would love to talk about that further down the road, about how can we create a better and more knowledgeable society regarding this technology that will definitely change the way we live and behave. Bueno, si no hay más preguntas, agradecerte, te agradecer, meu caro, pelo tempo, agradecer a todas las personas que están en el streaming, y vamos a dejar igual grabado esto para después, lo vamos a subir más tarde con todos los links, y ahí tienen para conectarse con Vinicius. So, well, thank you, Vini. Glad to have you on board, and thank you,
Muchas
everybody.
gracias.
Bueno, nos
Bye bye.
vemos. Chao, chao.